Welcome to my YouTube channel, A Brainery of Civil.
Today I am going to solve the first assignment of Foundation Engineering. I have already uploaded the videos of Geotechnical Engineering 1. Okay, so this is Foundation Engineering. So it is the first assignment. Shall we start? Okay, first question. In a compaction test, G, W, S, E, gamma W, gamma D represents the specific gravity, water content, degree of saturation, void ratio, unit weight of water and dry unit weight of the soil. The equation for 100% saturation line will be, okay, so we know maximum dry density or dry density is equal to gamma D is equal to G gamma W by 1 plus E, and we already know the relation E is equal to WG by S. I am placing in place of E, G gamma W by 1 plus E is equal to WG by S. He asked 100% saturation line equation. 100% saturation line equation, S is equal to 1. So place S is equal to 1 in this equation. G gamma W by 1 plus WG. Okay, so the answer will be B for question number 1. Now coming to question number 2, the observed value of standard penetration number for different depths is as follows. Number of blows required to penetrate for first 150 mm is 6, for next 150 mm is 6, for next 150 mm is 8. Okay, so what is the standard penetration number? So I am writing definition here. Standard penetration number is equal to number of blows required to penetrate the sampler to 300 mm excluding first 150 mm. Okay, so that is standard penetration number is the number of blows required to penetrate the sampler by 300 mm, provided it should not included the penetration for top 150 mm. Okay, so for top 150 mm this value, this 6 number of blows excluded, the remaining 150 mm plus 150 mm, total 300 mm. So total number of blows will be 14 blows. So the answer will be C for question number 2. Okay, and coming to question number 3. So the undrained cohesion of a clay soil sample is 15 kilonewton per meter square. So that is Cu he has given, it is 15 kilonewton per meter square. What would be the expected unconfined compressive strength? Unconfined compressive strength is Qu. Qu is equal to how much? We have a relation Cu is equal to Qu by 2. This is unconfined compression test, UCC test. So from this Qu is equal to 2 into Cu. 2 into 150 will give you 30 kilonewton per meter square. So the answer is B for question number 3. Okay, and very simple direct question. So the porosity N is equal to 30%, that is 0.3. What is the value of E? We have relation between E and N directly. So E is equal to N by 1 minus N. So what is N? It is 0.3. 1 minus 0.3 and it will give you 0.428, that is 42.7%. It is approximately 43%. Answer is C for question number 4. Now coming to the most important concept for throughout the soil mechanics is consolidation. So there is a question in this. The following data are given for a soil sample P0 100 kPa and delta P 150 kPa and Cc is equal to 0.4, E0 is equal to 0.8. Consolidation settlement of the sample of height 20 mm. So consolidation settlement, we have a formula, the most important relation. Consolidated settlement is delta H Cc by 1 plus E0 into H naught log P naught plus delta P. So you will get, what is Cc? It is 0.4. 1 plus E naught is 0.8. H naught is initial thickness of the sample, that is 20 mm. And log P naught is 100. 100 plus 150. If you will solve, you will get an answer as 1.768 mm. Approximately 1.77 mm. Okay. The most important relation is this one. So you will get different types of questions in this concept. Okay. So the answer will be 1.77 and it will be option A. Okay. And coming to next. A granular soil sample was tested in the laboratory. The volumes of the voids and solids particles are 2.25 and 4.5 respectively. The specific gravity of a soil sample was found to be 2.65. E has given E max, it is 0.8, E minimum, it is 0.3. What would be the relative density? The consistency of the soil based on relative density. First of all, relative density dr is equal to E max minus E natural divided by E max minus E minimum. So in this expression, we know the value of void ratios at maximum value and minimum value, but we know natural, we do not know natural void ratio. So we need to calculate void ratio naturally. So that is E natural. For that he has given data. E natural is equal to volume of voids divided by volume of solids. 2.25 number of voids are there out of 4.5 solids. So you will get it is 0.5. So isme dalo, you will get 0.8 minus 0.5 divided by 0.8 minus 0.3. So you will get dr is equal to 0.6, that is 60%. And there is a table for this. If dr lies less than 15, it is very loose. If dr from 15 to 35, it will be loose. If it is 35 to 65, it will be medium. And it is 65 to 85, it will be dense. If it is greater than 85, it will be very dense. Okay. So you got dr value as 60%, that will fall in this category. So the soil sample given is, it is of medium dense. Okay. So the answer will be B for question number 6. Clear? And now question number 7. Which one of the following represents over consolidated soil? So over consolidated soil means present applied stress in the soil is less than previously experienced maximum stress. For example, it is an area. In this there is a 10-floor building, let us assume. So in 2000 year there is a building of 10 floor. Now in 2022 I have removed completely, there is no building. So here in the 2000 year, as there is a building and now it is not there. So here soil already consolidated, that is compressed. But here stress is more stress. Here less stress. Why less stress? I have removed the structure. That is, in the past itself, the soil has been compacted to its maximum limits. Okay. So the answer is A for this question number 7. That is, present applied stress is less compared to the past stress. Clear? This is answer. 7th question, answer A. And now question number 8. The most important question. Listen carefully. It is a problem. A 15-meter thick clay layer is overlain by 5-meter thick sand layer. First of all, let me draw the diagram. This is 15-meter thick clay layer. And there is 5-meter sand layer. Okay. The saturated unit weight of sand, it is 22 and clay it is 90. This is gamma saturated. This is gamma saturated. Determine effective stress at depth. This is 5 meter at a depth 10 meter from the ground surface. So here it is 10 meters. Okay, this depth will be 5, this depth will be 5, total will become 10 meters. At this XX level, I need to calculate effective stress. Okay, considering gamma W, he has given it is 10 kilonewton per meter. First of all, I will calculate total stress. Total stress sigma at 10 meter. Okay, sigma is equal to gamma saturated into height, that is 22 into 5 plus 19 into 5, and pore water pressure U is equal to, as the water table is at the ground surface, water table will rise until ground surface, that is 10 into 10, it will be 100. So if you calculate this value, you will get it is 205. So effective stress is equal to total stress minus pore water pressure. Sigma means total stress, U means pore water pressure, and effective stress means total stress minus pore water pressure, that is 205 minus 100, that will be 105 kilonewton per meter square. Most important 2 marks question will come in this GATE exam. Okay, so it is 1.5, answer is B. Clear? Now question number 9. In the soil deposit of question number 8, so that is earlier question data we need to carry. Find the change in effective stress and total stress at 10 meters depth from the ground surface when the water table is lowered by 5 meters. So this is 5 meters layer sand, this is 10 meters layer clay. Okay, so earlier the water table is somewhere in the ground. Now this water table has lowered to 5 meters, that is this is the water table level. Okay, and in this at 10 meters depth, I calculated sigma and U and sigma dash. Sigma is equal to, in the last problem, what is sigma? It is 205. Okay, and U is equal to 100 and sigma bar is equal to 105. Okay, now at the same layer, this layer, XX layer, let I am assuming it is X1 layer, this is XX layer. At XX layer, in the previous case, total stress is 205, pore water pressure is 100 and effective stress is 105. Now in this case, he has given unsaturated bulk unit weight of sand. So this is 18 gamma bulk, and here it is a saturated because water table is laid above. So saturated unit weight of clay is 19. So for this case, I am calculating total stress is equal to 18 into 5 plus 19 into 5. You will get it is 185, and pore water pressure U is equal to 10 into 5. So the water will rise only up to 5 meters. It is 50. Effective stress is equal to 185 minus 50. That will be 135. So in the second case, total stress is 185. Effective stress is 135. He asked us to calculate in the previous case to the present case what is a change in total stress and what is a change in effective stress. So sigma minus sigma, in first case I am taking it is 1 and in the second case I am taking it is 2, that is 205 minus 185. The difference is, let I am assume delta sigma, 20 kilonewton per meter square, and delta sigma bar is equal to, here I am sigma 1 bar, sigma 1 bar minus sigma 2 bar, so it will be sigma 2 bar. So 105 minus 135, it will be minus 30 kilonewton per meter square. He asked us the change irrespective of the sign. So what he asked, change in effective stress and total stress. First, change in effective stress. Change in effective stress is 30 and total stress is 20. 30 and 20 are the answers. Okay, not 20 and 30. Be careful. Clear? And coming to last question, it is a graph, very important graph for direct shear test. So if we plot a graph for data obtained from the direct shear test, so we will draw a graph for direct shear test, that is shear displacement on x-axis, and change in height on y-axis. Okay, so now if you will draw a curve like this, there are two curves for dense sand and loose sand. So this is a loose sand curve, or this is normally consolidated clay, and this curve is for, I'm drawing with another thing, this is for dense sand and over consolidated clay. So in the options, loose sand will always compresses, right? This is change in height, means it is going down, okay, for loose sand. So that is loose sand always compression occurs. For dense sand, first compression, then expansion will occur. So that is for dense sand, compression initially, compression and then expansion occurs. Okay, so for dense sand initially compression and then expansion occurs, statement 1 is correct. For loose sand always compression occurs, statement 4 is correct. So which of the following are most appropriate? 1 and 4 are the answer. So answer D. Okay, so all the questions were completed in Foundation Engineering 1. Okay, this is the first assignment for this course. It is a 12-week course, so please try to get all the concepts in this. There is some of the questions related to consolidation. Consolidation is the most important topic. The type of questions you will get in GATE exam as well as all the important exams. Okay, if you have any doubt or else if you want any some other assignments, please post your comment in the comment section. Thank you.